Hi, everybody. Welcome. My name's Adam Penna. I am here to continue the conversation in 3D printing and additive manufacturing. And it's a good time of year to check in with what's been going on out there. I today have two guests joining us from the Rochester Institute of Technology, RIT. Wonderful to have both Michael and Irtaza here today. So welcome, guys. How are you doing?
Hang it in there, Adam.
Good. I know.
Pretty good.
I know. There's been a lot of Michael and I have some history early in the program. You guys are both in the engineering program at RIT. Is that correct?
Yeah.
Yep. Mechanical engineering technology. So
yeah.
we can get into a little bit the sort of finite differences if you want later on, but
tell us a little bit more about the actual program itself.
Well, it was kind of funny. Another favorite podcast of mine, it's an engineering podcast. A viewer had submitted a question about this, and they were like, "Yeah, I think it's kind of more like tech school." And I was like, "Well, tech school is an awesome route for a lot of people, but it is still like a 4-year program. It's basically you cover the fundamentals of engineering and then some. What it boils down to is our mathematics courses are a lot more condensed. And as a result, our classes that would traditionally in engineering courses incorporate more calculus heavy work actually wind up being more hands-on and more direct theory. So that's kind of, it's more of an experience thing. So
it is
great for manufacturing.
Yeah, it is. It's great to kind of have that full breadth of a view of things as you're going through it. And Irtaza, how's it been for you getting in there?
It's great. I was originally supposed to be an ME, mechanical engineering. I was accidentally put into this program. When I found out that we don't do, so the MEs actually do a lot more theory than we do. We go in, like he said, with the application. So you can tell an ME, hey, do the math behind this part, but they can't, the probability of them being able to make that part or put it into application is very low. You come to an MET student, we know how to make things work. We're good with our hands. Yes, we may not be the brightest when it comes to the mathematics, but we can definitely put you something together.
Yeah, and I've witnessed that in person myself. I had a project that I did with Michael about a couple years back. Was that when you're getting started? Because you're right at the end. Let's clarify that you're at the end of your program right now. So talk about that. Where are you right now, and what's left right now?
Gosh, I'm.
It's been
a long ride for me personally. Where do I begin? It's been, I took a little bit longer to get through some of my math courses. And so I just, funny with the stress of the pandemic and everything, I ended up the last 2 higher level courses I had to take, I ended up just blowing them out of the water. So I don't know if it was the extra stress or what that kind of motivated me, but it was great. From here on out, there were project-based courses through this fall semester. And in about a week and a half, I'll be all wrapped up. We are just in the sort of compilation of all our, we go through, verify and validate, design measure phases for developing a mechanical system, and then employing that in use and kind of the real like nitty gritty of meeting target demands for a particular market. And so that's a great project. That's called Machine Analysis and Design 2.
Nice.
So it's kind of like our capstone. So that's my big focus right now. And after that, I will be free as a bird to kind of network and explore and maybe look into, furthering my education, whatever I decide as time goes on. So.
Sure. Irtaza, where are you in your journey? Are you at that same point?
Well, yeah, so I am technically in my 4th year right now, but I am graduating a year early from the major. I end up starting my engineering PhD in the fall with the RIT.
Awesome.
Definitely been the hardest 4 years of my life, not gonna lie, especially with this pandemic going on. But I definitely got me thinking about what life skills I want to learn, what I need to know for the rest of my life. Got me planning out the next 10 years of my life.
Yeah, no, that's the big part of it. Obviously, this is the big change, right? What you're actually going to be applying this to going forward. But I want to address that something before we go forward, a little bit of what you were talking about there. And it's it's not so much the elephant in the room nowadays, but it's what's been going on in all our lives. We've been dealing with this pandemic all in our own ways, and it's challenging for everybody. So you had privilege now of actually having, normal regular schooling up until this last, 9 months. So really it's happened at the end. There's some people that are coming into it right now. Wow. To start out and have certain things that you can't actually do as much as you could a year ago. But what is that reality now? What does student life look like? It sounds like you're able to apply yourself. Michael, it sounds like you've been focused more and able to do a lot more. So give us a kind of look into what the last 9 months have looked like for you and some of the changes from how it was before.
So that's with regards to me, right?
Sure.
So,
Yeah.
So I'm a learning assistant for mechanical dynamics with applications, and and I'm also a learning assistant for statics, which is one of the first for the second year mechanical engineering technology students end up taking that course, and I've seen their grades. They're not doing too hot right now. A lot of people are really struggling to get through this semester, mainly because nobody's actually properly learned in this type of environment before. And I, personally speaking, if I had gone through statics the way these kids are going through it right now, I don't think I would have made it to my fourth year. Statics is a fundamental course, right? It makes a basic understanding of the engineering world. Like, you can simplify the majority of your problems to a static problem. But these students don't have that ability at the moment, and their minds aren't opening up to the possibilities of the further classes, like how to implement the other classes alongside the statics. And I think that we're going to see a very high dropout rate from the major, seeing that the freshmen and the sophomores aren't doing too hot in the engineering classes, or we're going to see engineers that are not capable of taking on real world problems because they just don't know what to do.
That's obviously what is real right now. There's a lot of things that can't be done, or they're finding a new way to do it. It's not quite, that whole process hasn't evolved into the proper way to do it yet. But it, kind of being where you guys are at the end of the coursework here, I'm sure you had a lot of hands-on experience, which I know, Michael, we've dealt with that, through a project you were doing in the past. But there's so much more that's been going on. But you're just at the very end. I mean, I know it's almost been the last year that this has been going on, but I think you've been in the best spot compared to some other people on the other side that are coming into it right now. And I'm glad you're honest about that, the struggle that's going on there, because a lot of times people like to make it rosy, but there's a lot of things that we have to work on together and be open about, because if you don't know there's a challenge, how could you address it? And that comes in your normal business life when you get out there in the world too. So, I mean, it's a good challenge. I mean, I hate to apply the word good to it, but it's a challenge, that obviously as human beings, we have to help each other through. So you being a teacher's assistant is awesome in helping out with that, and kind of, I'm sure you're coming up with new ways to do things that weren't done before. So, it's a different challenge right now. And I'm glad you're open about what is actually taking place. But so going forward right now, I guess Rochester Institute of Technology, RIT, is a beautiful campus. I'm kind of jealous that you guys are there. I know that it's a very neighborhood-like campus, and so there's a lot of good things around it. It's just a good community around it and things like that. And I'm actually from Buffalo, New York, so it holds a place in my heart too.
Go Bills.
Yeah, hey, all right. Wow.
Yeah.
I live down in Austin, Texas right now, so I get the heat, but that's okay.
Oh man.
Right. Yeah,
well,
yeah.
my first team has to be the Steelers, which 10-0 right now. I mean,
yeah, hey, there you go. There you go. Yeah.
Buffalo, all my time in Rochester, Buffalo is just, it's happened for me. I'm a Bills fan now too. So
yeah, and a great fan base there, and it's wild. My dad lives up there, and so I was just kind of messing with him, and I said, it's kind of wild that they're having the best season that they had without any fans. It's usually the fans are what makes it. It's like, hey, maybe the fans they needed to kick back and just let the team play.
Yeah.
Just joking. It's man, that stadium's awesome to be there, and that's such a fun and entertaining thing to do. So what have you guys kept yourself inside of this last 9 months to do to not go so crazy from all the changes that are going on, and what are some of the things you've done to kind of get through this?
Well, gosh, Irtaza made some really good points about students kind of struggling with the changes, and I can't really articulate how, but I've been kind of thriving with it, and I think it's just because I've given myself a short leash, and it's like, Mike, if you, in past semesters, if you allow yourself to slip, there's kind of a support structure there. There's a lot of available office hours, TAs, people you can physically visit to kind of help you with concepts, and that's not going to be there as a safety net now. So you really need to make sure you're on top of things. And with that in mind, my sort of seclusion survival tactic here is kind of focus on my work. And then outside of that, you start to notice that you're sitting a lot. So I go on very, very long walks. I mean, I went on a walk with a friend and they were just like, this is the first time I've reached 11,000 steps in one day. You do this regularly? And I'm like, yeah, I mean, so long walks and sticking to my schedule, as boring as that sounds. And I'm, you know, I heard from one of your podcasts, you're a musician too, and I've picked up a few different songs on guitar too.
Hey,
so
nice.
Little things, you know?
Yeah, little things to keep you busy. How about yourself, Irtaza? What have you been doing?
I completely agree with Michael. If you don't have a schedule, you're gonna end up sleeping in the night. Sorry, not sleeping in the night, sleeping in the day and working through the night. Unfortunately, that's just my natural frequency. And if I wasn't able to maintain a schedule, I'd be going pretty crazy right now. Not gonna lie.
It's important to kind of keep those things that keep you healthy and working on the mind. I know a lot of people, including myself, I do walking almost every day, more than before. Like even today, I have a plan to go after this for a long walk. So it's like if you don't do certain things to keep yourself healthy and the changes, I think a lot of people are secluded and they don't even go outside to take the walks, or they're in a place where they can't do that, which is a shame, So it's you got to kind of count your blessings and do what you can to get by, but at the same time, you have a community there. You have a community of students, different people that are struggling and going through things. So I'm sure it's been a lot of getting to understand each other in a different way when you can, because you have your close community there. So also, I guess in the past, Michael, you and I have worked on a 3D printing project, and working with metal and laser powder bed fusion. And I know, Irtaza, you have behind you right there looks like another 3D printing machine. So what has being in 3D printing and additive manufacturing, it's like we see a lot of different people come from the academia coming into the industry and bringing a lot of different skills. So I know, Michael, you touched on a lot of different 3D printing in your time there, and it was I believe you were working with Frustum back then, and they were purchased by PTC. So the great kind of transition there. But at the time, were you interning with them or just helping them out? What was that?
I was interning with them, and it was really cool, because I worked directly with the CEO at the time, Jesse. So his whole mantra was kind of, I suppose, path for me was just, dude, figure something out. Figure something out that could work with what you're doing right now, where you are with being out here. Take advantage of this opportunity, and that led me to reach out to some kids on the BAJA team who had a part. That led me to reach out to you, and we had this really great end-to-end project where I got to ultimately put this thing in a compressive load and see what type of mechanical behaviors it exhibited. And that was my first, full-time experience with, an end-to-end design, optimization, manufacturing, and testing type of project. And it was really, I knew of the potential for additive at the time, but with like direct metal laser sintering and all of the finite geometries that were really capable with some of these processes, I was like blown away. And ever since, I've been bitten by the AM bug and trying to figure out how to like wriggle my way into industry kind of. So that was awesome. We had a launcher project too. Irtaza, I know you're familiar with this, the Marshmallow Launcher. That's our mechanical dynamics course.
Cool.
And you build a marshmallow launcher and you use dynamics to kind of calculate, your frictional losses, your spring energies, and then once the marshmallow leaves the tube, its trajectory and where it's going to land, and then you're scored on the physical performance relative to your calculations. Pretty much. Actually, not even relative, but just, is it adjustable enough to hit random targets that the professor sets? So for AM, the carrier for the launcher, this actually shattered. I had a younger guy in a group with me who absolutely was losing his mind over the deadline for the performance part of the project. And he actually started jamming wood screws into it because it failed perfectly where the cross bolt goes through. So I stop him and I'm like, dude, you are freaking out. Let's just go print another one. So that was kind of the beauty of AM for me. You didn't have to go through all this extra problem solving, just load a file and print another one.
Yeah, that's a big part of what the industry is now facing with, kind of replacing virtual inventories out there. It's been over the years, people store parts like tools or jigs or fixtures and things like that, or molds. And those are something that can be digitized and stored that way, and be available to print at any time, modify, change, come up with the next rev, whatever it is in that digital world. And that's part of these buzzwords like the digital thread, and you're talking about cradle to grave with a project. Frustum over there, again, was doing a lot of the generative design. So that bracket you were working on was about a 10-inch bracket or so.
Yes,
And you were looking at stresses related to what was going on in the buggy. And so I know we looked at different things with the actual shape or structure of the part, because we were working with Frustum. So it came up to like something very organic looking for what it was. But
Alien
still,
versus Predator.
yeah.
So
okay.
cool.
Yeah.
So
yeah.
cool.
Such
just
a
these...
wicked looking part. Yeah. Yeah. So you talk about that, and I mean that's like that's part of that design that you could do totally different inside of some of these softwares out there, but specially made for what you could do building layer by layer. So
Yes.
and you get into like something very simple like that Marshmallow Launcher that you have there. Could probably be done. Was it done on an FDM machine? Something very quick, and it's
yeah.
polymer. Yeah,
I want to say this was PLA.
Okay. No. Okay.
I can't.
No.
But it was great. It took a few hours, and I had another part ready, and we went for it.
Yeah.
But generative design, I mean, you mentioned it. Just that was another thing that blew me away. Understanding how things like minimal surfaces can be employed, and sort of redirecting your stresses. I mean, you're designing. If you think about, like, my favorite example is old school drag racing, actually.
Mm-hmm.
And they took a Pontiac, I think it was a 421 car, and they just hole sawed holes in the frame.
Mm-hmm.
And at the time, that's the most simple lightning pattern that you can do, because when stresses go through a part and they hit a circle, the stress concentration kind of goes around and back out. And so it's the most simple and effective, like sharp corners are bad for stress risers. But now imagining, building a stock drag racing car in today's day and age, like where we could potentially be in a world where we are powder bed printing things the size of car frames or car subframes. I mean, just imagining the structures capable and the lightning patterns that you can get away with, because these smart algorithms are kind of figuring out how to direct material in such a way that stresses and forces are directed and displaced in the most efficient manner with the least amount of material used. And so I just, it was really kind of a exciting time for me, and working with that project, and between these two different things, it's like night and day. But still, the possibilities with AM, just, I think they're endless. They will be endless.
Yeah, we're getting to that tipping point. It's been a wild ride here through the pandemic. If you've been paying attention to the industry inside of 3D printing, there was a time there where there was a supply chain, that was interrupted, and especially in the health industry with PPE and personal protection equipment and other different things that no one had. Swabs, that was a big, a big story that came out with 3D printing, and the way that was addressed right away in the interim until normal manufacturing could then catch up. But it was a really big, eye opener for everybody, that, for businesses out there to go, wait a minute, just because, maybe I'm not 100% in production with a 3D printer right now, depending upon the application, there's still a huge part that's a risk mitigation, and when certain things happen, it's nice to know that, like you're saying, you broke that, marshmallow slinger out in the field. It's the same thing, there's a whole supply chain of how he thought he would have to get a replacement, and how long that was going to take. And it was driving him crazy in the head. And then that little thought process of, wait a minute, the lab back there, let me just go stick it on there. We'll print another one. And, that's a very small example, but it's a real world example, because it happens everywhere, and people's eyes are opening up right now to that, that relief that you can get inside of a supply chain with a 3D printer and with a solution like that, where you have your second choice is to go and have these all printed out a certain way right now. It's going to be going forward as production increases, as the rate of production increases inside of these machines, and that's happening exponentially right now. You see all the, companies are looking at speed and cost and finding a way to come up with larger frames of doing things and more materials. And it's getting really exciting. It's starting to get to the point where it is becoming more mainstream, and it's not just a bunch of, bells and whistles and, hey, how cool is this? It's actually something you could use in everyday life. And for that, I'm grateful. It's kept it interesting, and especially seeing that rise over the last 9 months, especially early in the pandemic and the lockdown, and look at what people were going through, and to see 3D printing just out there right away and solving a lot of localized problems and localized issues. So it is exciting when you can flip that switch and go, wait a minute, we don't have to wait to get another one of these marshmallow slingers. We can go print it. That's what it's all about right there. It really is. And then when you come into the design side and realize how much you could do, like you found out with that bracket, there was just so many different ways you could approach building that bracket to fit in what you needed for the stresses you had, and to think about that in that way. It's really neat. And how many iterations? We went through a few different iterations.
Oh my gosh.
Yeah. So I mean,
it's
yeah, to go print all those out and or to manufacture each one of those and build a actual mold or a jig or fixture, and hey, that one didn't work, we got to redo this whole process again. That takes a while. And so in those circumstances where you can do that, that's where you really start to find that value. And I think you saw that in that project, and it sounds like you saw that with the marshmallow slinger there. So
yeah.
Cool. I mean, so let's talk about where you're at right now. You said you're both about, what is it, a week out from everything, a week and a half until you get through.
We're done with finals, something like that. Yeah. I think it's the last day.
When is that, Monday?
Yeah, I think the official end of the time frame for finals is December 11th.
Nice.
But with projects, I think the first, so next Tuesday of next week, I have to have my final presentation and report together for my MAD class. And then the 8th, I have to have my report ready for thermal, and that's it. So I'm completely washed of responsibility for those classes by the 8th. Yeah. Hopefully sooner. Hopefully we really crank these out and have a good quality result. But we're mostly finished anyway. So
and you're in the same boat. Irtaza over there, you're in the same boat as far as you're finishing up here in the next couple of weeks.
Yeah, I have a couple of major projects left. We did finish our MAD 1 project, which is actually the class that's right before the one that he just spoke of. I have a plastic spinal right after this. I have another 5.5 hours to finish it, so got to do that afterwards. Several more projects that I do next week, and then towards the end of next week. But after that, I'm done for the semester. I can't wait to clock out.
Gosh, I like to say I am, I'm listening to your schedule, and I remember those days, and when you're in full-time school and dealing with everything else. Yeah. So, I mean, my gosh, congratulations on getting on that side of it. It's really a good feeling. I know right now you just want everything to be over, but you're right there. So that is a good feeling. That's really awesome. Exciting. So you're doing anything wonderful for the holidays? By the way, before you answer that, I just want to let you know this. So this particular episode will probably be coming about right when you guys are finishing, in a couple weeks from now. So that'll be really cool that it kind of paralleled with what's going on, and it's exciting. I'm so glad you're able to do this. I know Michael, we've been talking in the past about things, and then this just kind of came up as it wasn't even on the radar. We were like, hey, that would be really neat to do something like that. And my whole reasoning, part of it was, wow, right now there's just so many different things happening. And I've seen, the class of 2020 in many ways. I have a daughter that is now in the 6th grade, and so she is right in the middle, of everything. Yeah. And then I have some nieces that just graduated from high school at the end of last year and just going into college. And so I've heard their stories. Yeah. And so it's really hit home. And I know when I was talking to you guys, they're right at the end. So that's the other perspective of now going out there in the world or moving on to the next, section of school that you're going to get into. It's a matter of now, wow, that's another huge step at this time during this pandemic, where it's a different time, you know, and it's like a different way of things, looking at things and approaching things. And you have to be very nimble-minded and very networked, you know, getting out there and talking to people. So Michael, I'm glad we kept in touch. And Irtaza, I'm glad that we're starting this conversation, because any way that I could help with what you're going through, and I'd love to, you know, keep in and on tabs of what's been going on with your progression after this. It's a really interesting time for all, but I think the biggest side of it that I see that's helping is when you can do stuff like this, when you can network with people, when you get out there and talk to the industry. And it's tough now because it's not those open trade shows that were there where you could just show up and learn and talk to people. It's more of a virtual world. You know, I've seen that over the last 9 months. All of our events have gone from being in person to virtual. And it's been a lot of technical difficulties for everybody. You know, we saw a little bit of that before we got started today. But it's a fact that networking and getting out there and being open and to opening your cameras and talking to people on the other side, that's a big part of where the world is today. So I'm just excited for you guys. I don't know if it shows from over here. I'm like,
oh, you can see it, man. Thank you.
Yeah, we really appreciate it. I mean, even the opportunity to have this conversation with this platform is just awesome, I think, for the both of us. So
yeah, no, and I think you're both very interesting, young men as far as getting things going in your life. And there's a lot of good things that you've been going through to get where you're at. So I have no doubt that they'll find the next best fit of what's going on here. But it's awesome to touch base. So, thank you for being here today. But before we go, is there anything else? I'll ask Michael that, and then we can go to Irtaza. But is there anything else that you would like to share while you're here?
Well, just that I'm, again, really excited for the next few steps, and hopefully in the context of AM and industry, that's kind of where my focus will be. And I'm just excited in general to sort of sit back and watch what the future has to offer. I think actually, Irtaza, you might have a couple of cool things. So I kind of want to shift my focus to that. He has, I mean, he's been working on some really cool stuff. So I wanted to hear more about that from him, because I know it's been a while since we've caught up on that.
All right. What's going on, Irtaza?
So I don't know if Michael actually told you this, but I have patent pending status on one of my inventions. So I filed a patent and a continuation in part. And my goal with this product was to license it to a manufacturer and obtain royalties off of it for the rest of my life.
Sure.
And in order to show this company my idea, obviously there's a patent, but a patent is just a bunch of words. It does have figures in it, but it's been consolidated to the point where it's a very simplistic design. And what I had to do was come up with obviously a prototype. And I think the best part of additive manufacturing is the fact that you can make almost anything that you can model in a way, as long as you know how to properly insert the supports, do proper infill geometry and density. I think you could print anything, right? And I spent the last, I would say about 1.5 years of my life making this guy right here. Now, I can't tell you on camera exactly what this is. I'm sorry.
Well, I'm glad you're showing it, though. That's pretty cool.
Yeah, because it would be hard to know what the application of this product is without me explaining to you. So which is why I'm not worried about putting it out there. But basically, when we're talking about the how many reiterations you have to go through in order to get to a final design, I think the most obvious thing on this invention is this. So this clip right here is it's supposed to clip around something, right? And it can extend a little. It's that bungee cord in the middle. But the problem I was having was when it would come out of the actual body, right? It's parallel. This is parallel to the body, but I needed it to be 90 degrees. So I 3D printed several, I would say I went through maybe 40 of these, which is where I was able to 3D print my own ball joint. Right.
And, beautiful. Yeah.
You talked about not having to recut a mold every single time that you wanted to fix a little bit of the geometry. Right. I finished my minor in plastics engineering, so I know what goes into designing a mold and how much it costs. So the fact that somebody doesn't have to put out tens of maybe thousands of dollars in order to come up with a small product, I think that's beautiful. I think anybody can be an inventor now. I think anybody can be an engineer. I think we've been given a very powerful tool, and that it doesn't take a lot to understand it. Like there's artists on, like you would expect only engineers to be really focused in this. No, there are people that work with pottery that are 3D printing their own clay pots. There are people that are 3D printing circuit boards. Like the possibilities with additive manufacturing are endless. And I think we've exponentially increased our ability to solve problems with this on the fly. You know, they were able to 3D print a tool in space that they didn't have. You just send them an STL file, and the astronauts in the International Space Station can make their own tools. I think this is one of the greatest inventions of, I think, in history right now, to be honest.
No, it's exciting. I'm glad you're excited about it. You know, that's why me and Michael have kept in touch, because we both get excited about this. And some people, it's not their thing, you know, but hey, when it is your thing, there's a lot to get excited about. And that's what I've been doing, is actually focusing on the positive side of things over the last 9 months, because we've all been going through our challenges. But hey, when you're building, it sounds so like, you know, hey, another buzzword, but when you're building a better world, I mean, my gosh, that's just exciting. I used to think that I just was, I've said this before, but I used to think it was just about the applications, especially coming out of school. I was like, oh, there's just so many, and it is, there's so many cool applications. And all of a sudden it came to the point over even the last year where I was like, you know what? I get really excited because it's improving life. It really is. You know, it's improving life in healthcare and everything from aerospace and, you know, automotive. There's just so many things that are happening. And you were saying you can go anywhere with it, you know, Marshmallow Launcher. I mean, there's fashion, there's so many different sides of it that are actually just accentuating what can be done. People can be more creative. People can use what they have and make it better, lighter, stronger, faster, you know, whatever it is, it's exciting. So thank you for both for being here, Michael and Irtaza, and I wish you the best of luck in the future. I know we'll keep in touch. So you guys, good luck at the wrapping this all up, and I'm sure we'll both be looking forward to a successful 2021. So thanks for being here.
Absolutely. Thanks for having us.
All right, guys, take care.